I am Dr. C. Southali. I am going to discuss about the subject EE8602 Protection and Switchgear. Unit 1 is Protection Schemes, and now I will discuss about principles and need for protection schemes. So this is general electric power system. So in the diagram you can see 1, 2, 3, 4, 5 and 6. So the 1 is the electricity is generated at the power plant, and 2 is the voltage is step up for transmission, and 3 is energy travels along the transmission line to the area where the power is needed, and 4 is voltage is decreased or step down to another substation, and 5 is you can see in the diagram that is distribution power line, and 6 is the home, that is which carries that electricity until it reaches the home or business. So this is the basic electric power system diagram. So what is mean by system protection? System protection is the art and science of detecting problems with power system components and isolating these components. So the protection symbols, there are many symbols, that is current transformer, voltage transformer, capacitor, circuit breaker, bus, transmission line, delta connection, static load, two winding transformer, surge arrestor, fuse. So these are the protection symbols. So why a system need protection is, so there is no fault free system ensuring the safety of personnel. So usually faults are caused by breakdown of insulation due to various reasons, that is over current, over voltage, lightning, etc. Principles of protection schemes. So the objective of the power system protection is to isolate the faulty section of electric power system from rest of the live system, so without any severe damage due to fault current. Actually, circuit breaker isolates the faulty system from the rest of the healthy system. And the main philosophy about protection is that no protection of the power system can prevent the flow of fault current through the system. Quickly, it can disconnect the short circuit path from the system. And the need for protection. So the power system must maintain acceptable operation 24 hours a day. That is, voltage and frequency must stay within certain limits, and protect the public, improve system stability, minimizing the damage to equipment, protect against overloads. So when failure occurs on any part of the system, it must be quickly detected and disconnected from the system. There are two reasons. That is, if the fault is not cleared quickly, it may cause an unnecessary interruption to the service of the customers. Second is the rapid disconnection of fault apparatus limits the amount of damage, and it prevents the effects of fault from spreading into the system. And the detection of fault and disconnection of fault can be achieved by using the fuse or relays. So main protection schemes are, that is the elements of protection schemes are current and voltage transformers, relays, circuit breakers, batteries, fuses, lightning arresters. So first is the current transformer. It consists at least two secondary windings. First one is usually designed for measuring, the second is for protection. The secondary of current transformer is almost called star connection. So here in the diagram you can see the current transformer, and this is the voltage transformer, consists of two windings. First is the star connected, and the star point must be earthed. So the second winding is connected by open delta connection. So these are the diagram. And relay purpose, that is isolate the controlling circuit from control unit, controlling high voltage system with low voltage, controlling high current system with low current, and logic functions. Circuit breaker, there are many circuit breakers, that is voltage, low voltage circuit breaker, magnetic circuit breaker, medium voltage circuit breaker, and high voltage circuit breaker. Fuse, so fuse are selected to allow passage of normal current and of excessive current only for short periods. So it is used to protect the low voltage or current rating devices. Next is the lightning arrestor. It is a device used for electrical power system to protect the insulation damaging effect of lightning. All lightning arresters are earthed. And the main advantages of using protective relays is it detect the system failures when they occur and isolate the faulted section from the remaining of the system. And next is mitigating the effects of failures after they occur, and minimize the risk of fire danger to personnel and other high voltage systems. So what is switchgear? Switchgear is a combination of switches, fuses or circuit breakers used to control, protect and isolate electrical equipment. Next is it is used to de-energize the equipment and clear the faults. So mainly switchgear is consist of switching and protection devices such as switch, fuse, circuit breakers. And when the failure occurs at any part of the power system, a heavy current flows through the equipment and threatening the damage to the equipment. However, the switchgear detects the fault and disconnects the unhealthy section from the system. So in this way, switchgear protects the system from the damage and ensures continuity of the supply. So the apparatus used for switching, controlling and protection the electrical circuits and equipment is known as the switchgear. So switchgear equipment is essentially concerned with switching and interrupting the currents either under normal or abnormal operating conditions. So the primary equipment and components are transformers, breakers, insulators, isolators and bus, grounding, arrestor, switchgear, reactors, voltage and current transformers, regulators. And protective relay. So protective relay is a device that detects the fault and initiates the operation of circuit breaker to isolate the defective element from the rest of the system. The protection relays utilizes one or more of these quantities to detect abnormal conditions on the protection system. The main functions of the protective relaying is it was quite simple, and the secondary of the current transformer is connected to current coil of the relay. Whenever any fault occurs in the feeder circuit, proportionate secondary current of the CT will flow through the current coil of the relay, due to which MMF of that coil is increased. And this relay contact actually closes and completes the DC trip coil circuit, and hence the trip coil is energized. Essential qualities of protective relaying are reliability, selectivity and discrimination, speed and time, sensitivity, stability, adequateness, simplicity and economy. So the functions of protective relaying is the perfect removal of the component which is behaving abnormal by closing the trip circuit or to sound an alarm, and to disconnect the abnormally operating part as to avoid the damage to the rest of the system, and to prevent the subsequent faults by disconnecting the abnormal operating part to improve the system performance, stability, reliability and service continuity. Thank you.